All right, so today we're starting off our new unit and we're going to talk about systems of equations. So far what we have done with equations is you get an equation that's something like, I don't know, 3x plus 2 equals 8, right? And we would solve this and we'd get an answer, say x equals 2, right? And what this answer means is this is the value that when you put it in for x is actually going to make this true, right? When I do 3 times 2 plus 2, well, 3 times 2 is 6. 6 plus 2 is 8. That's the answer that makes this point or this equation true. Okay, so that's what we've done so far with solving. So what we're going to do now is now instead of having one equation, we're going to have two equations. So it's going to look something like this or maybe like this. Okay, so we're going to have two equations that are both true at the same time. Okay, and what we're looking for is instead of just having x equals, right? In this equation, there was just a letter x. So our answer was just x equals. But in these equations, we have an x and a y. So we're going to figure out what x equals and we're going to figure out what y equals. Okay, so that's sort of the goal that we're going to work through for most of this unit. Okay, so first of all, a system of equations. So a system of equations, okay, is a set of two or more equations that are both true. Okay, so two or more equations that are both true. For this year, we're just going to focus on two equations. We're never going to do more than two. All right, but it is a thing. There is such a thing as having more than two equations for a system of equations. Okay, the solution to your system, so the solution is the point that makes both equations true at the same time. Okay, so something that makes both equations true at the same time. So we're going to do two different things here. First of all, we're going to check to see if a point is a solution to this system. Okay, so for this one, I'm going to give you an answer, and I want you to tell me, like, is it actually a true answer or is it not a true answer? If I give you a number for x and a number for y, will it actually work for the system or not? Okay, and remember, to make it work, right, it has to make both equations true at the same time. So here's what we're going to do to check if a point is a solution to the system. So what we're going to do is we're going to plug in the point, which, remember, points are always x and then y. So we're going to take that point and figure out what x and y are from it and plug it into both of the equations. We'll simplify it and see what we get. If both of the statements that are left are true, then it's a solution. Okay, and if at least one is false, then it's not a solution. So it's an all or nothing type situation. They have to both be true or nothing. Okay, so before we talk about option two, let's take a look at an example. So we want to know, is 0, 2 a solution to that system? So the first thing that I'm going to do is I'm going to use this point to figure out what x and y are, right? So points are always x and then y. So what this point is telling me is it's telling me that x is 0 and y is 2. Okay, because the first coordinate is the x and the second one's the y. Okay, so now to check this, what we're going to do is I'm just going to plug it into those two equations and we're going to simplify it and see what we end up with. Okay, so my first equation says do y equals the opposite of x plus 2. So y is 2. So I'm going to write 2 equals the opposite of x. Well, that's negative 0 and then plus 2. Okay, so we plugged that in. And then we're just going to simplify it. The opposite of 0 is just 0, and 0 plus 2 is 2. So on this side, we get 2, and on that side, we get 2. And then we're just checking, is that true? Does 2 equal 2? Yeah, right? 2 is indeed 2. So that one worked. Okay, now we're going to do it with the other equation. So the second equation says x equals 2 minus y. So x, that's 0. So 0 equals, and then it says 2 minus the y coordinate. Well, the y coordinate's 2. Okay, so we're just going to simplify. That just means add or subtract or multiply whatever's there, okay? You don't have to worry about inverse operations or doing stuff to both sides. We're just going to straight up simplify. 2 minus 2 is 0. So we ended up with 0 equals 0. Does 0 equal 0? Yeah, it does. So we found that when we plugged these numbers into this system, it made both equations true. Okay, so is this a solution? Yes, it's a solution because it made both equations true. Okay. All right, let's take a look at the second one. Spoiler alert, this one's not going to work out. Okay, so this one's going to end up being not a solution, and I want to take a look at why. Okay, so the first thing we're going to do, just like we did before, is I'm going to take from this point, my x coordinate is 4, and my y coordinate is -2. Okay, the first one's always going to be x, the second one's always going to be y. All right, and then we're going to plug it in. So the first equation says x minus y equals 6. So x is 4 minus y is -2, right? Does that equal 6? Well, remember when we have 4 minus -2, that's like a giant plus sign, right? So that's like 6 equals 6. Yeah, that's true. Okay, so that's great. All right, now my second equation says 2 times x plus y equals 10. So I'm doing 2 times x, which is 4, plus y, which is -2. And we want to know if that equals 10. Well, 2 times 4 is 8. Okay, and then 8 plus -2. So 8 buckets of water and 2 fires. We're going to have 6 buckets of water left over. Does 6 equal 10? No, that's not the same number, right? So this one, that didn't work. Okay, so even though this point made one of the equations true, it didn't make both of them true. So no, it's not a solution. Okay, so that's how you can check. If somebody gives you an answer and says, is this the right answer? You can check it and figure out whether or not it is. All right, and then the second thing that you can do, all right, is we can find solutions by looking at a table. Okay, so what we do is we make a table and we would look for a point that appears in both tables. So I guess make a table for each equation. Sorry, I should have added that in. So you're going to make a table for each equation and then check to see if for a point that appears in both. Okay, so let's look at this guy right here. So we want to know what's the solution to this system. Okay, this equation right here, already have a table of values for. This equation right here, we already have a table of values for. So what we're looking for is we're looking for a point that shows up in both. Like here is the point 1, 7, right? 2, 6, 3, 5, 4, 4. So I'm looking for which one of those shows up in this table as well. And it looks like it's this guy, right? That's the only one that shows up in both tables. So that is my solution. It's the point that shows up for both of them. So my solution is the point 4, 4. Okay, now these two happen to be next to each other, right? They're right near each other in the table. Sometimes depending on where the table is, they might be a little bit offset, but you just want to always make sure that it's the same pair of numbers for both of them. Okay, so that is what we're looking for when we talk about a system of equations and we're trying to find a solution. So the solution to a system of equations is a point that makes both true. When you plug in the numbers, it makes both equations true. Okay, or you could think about it as it's a point that shows up in the table of values for both. Okay, so that's what we're talking about when we talk about systems. We're going to do a bunch with systems. We're going to talk about different ways to solve systems. And then we're going to look at some word problems, which I know are your favorite, with systems of equations, so that we'll practice that a little bit. But this is one of the more useful types of math, I think. So we will make sure that we hit on that.